Assalamu alaikum everyone. I am MD Ibrahim, back with another video. Today I am going to show you a PID controller. What is PID controller? A PID controller is a controller which is based on a closed loop system. And what is closed loop system? Closed loop system is a system which works on feedback, and this feedback is come from the outputs. Here input is a set point, and this set point is given to the controller, and the controller process an output, and this output is sent as a feedback as a process variable. And after processing, our controller make the output equal to the set point, and whenever our output becomes equal to the set point, then our curve will be stable. Our main goal is to make a stable curve, and this curve will represent that our system has become stable. So mainly today we are designing this PID controller for a water level system. Now see how we can implement this controller in a water level system. Suppose we want to fill a tank up to a level, but whenever we start to fill, it might get over the set point, and to get this set point we need to reduce some water. So we need to discharge some water, but after discharging we see that our water level goes below the set point. So we need to start to fill the pump again, and again we will see that our water level will cross over the set point. Then again we need to discharge the water. This process will be continued until got our stable point. So this PID controller is mainly work to stable things by achieving the set point. So we will see this PID controller on Siemens TI portal and factory IO. Now coming to the Siemens TI portal, you can see the ladder diagram of our PID controller, and we have also designed a PC systems train view to see the curve of our full process. With this curve we can see our stable point, and here in factory IO we have designed a water level tank, and here you can see our field valve and our level transmitter to measure the level of the water, and you can see its hole size is 300 centimeter of the full tank size. And there is a discharge valve to discharge the water, and the flow meter to calculate or measure the flow of the water. And there is a control section where we can start, stop, and giving the set point and see the process value. Our main goal is to match this set point and process value. Whenever the set point and the process value will be same, then we can understand that our graph will be stable. And here we set a set point to 132, and you can see our field valve has got started and our water is filling to the tank, and our process value is showing the value. And let's see the curve. There you can see the red mark showing the set point and the blue mark showing the process value. As you can see that our process value becomes much larger than our set point, which means our water level goes above our set point. There you go, you can see that our set point is 132, but our process value is 199. That means we need to discharge the water. So we will start the discharge valve to reduce the water, and we need to go to the set point. So we start the discharge valve, and you can see that our water level is start to decrease, and it will decrease up to the set point. And in the graph you can also see that our graph is declining, and the process value has reaches to 152, and it is decreasing continuously. We are almost close to our set point. We are almost there, and in the graph you can see that our process value has become much closer to our set point, and our graph is almost stable. There we go. We are just one value above. And there we go, we have reached to our set point. And in the graph we can also see that our graph is pretty stable now, and we have achieved our set point with the help of this PID controller. And you can see there is zero error. That means our controller works perfectly. And again, if we increase the set point, as you can see, I am increasing the set point to 154, and our water start to fill again. And you can see that our water level has already crossed the set point, but as our discharge valve is open, so it will make it stable again. That you can see that our value has become stable again. There we go, you can see that it's 155 and 154. And if I show you our graph, as you can see that whenever we increase the set point, the red mark goes above, and our green mark is also increased, and after a certain point it becomes stable. So you can see that. So here you can see our set point and our process value is equal. So this PID controller is implemented for a water level system, but it is not only we can implement on water level system, but also we can implement it in any closed loop system, just like setting a temperature to an exact value, or setting up speed, velocity, or other kinds of closed loop system. We can use this PID controller, and with this PID controller we can achieve our any kind of set point. So that's it for today. Thank you very much. Goodbye.